Alright, so this video is going to be the continuation of this elimination method solving systems series. So we're going to go through this kind of quickly. This first page I'm going to go through is literally a repeat of what we've already done, so it's just a matter of reinforcing those skills again. So addition property of opposites states that if any number added to its opposite, you get 0. Subtraction property of equivalent values states that if I take some number and subtract it directly from itself, you will get 0. The multiplication property of equality, if A equals B, then A times C must be equivalent to B times C, which is basically just stating that if you multiply one side by the equation, you must multiply the other side of the equation by an equivalent identical value. So, given the system, so we move forward here. So given the system of A1 and B1y and C and the other one of AX plus BY equals C, you need to have, okay, your A1 equivalent to your A2. Now, in all reality, it's really the absolute value of those need to be equivalent to each other, or you need to have the absolute value of B1 equal to the absolute value of B2, all right? So essentially what I tell my students is you're just looking at the number to start. The sign doesn't matter. The sign comes into play when we decide which property are we going to use, the addition property or the subtraction property. So what do we do if, A1 does not equal A2, nor does B1 equal B2? All right. So in this case, again, we utilize the multiplication property, okay, of equality. Okay, so the mathematical concept we combine this with is LCM, which is least common multiple. All right, and here's the deal. You can either do this mental math, so if you've got good mental math skills, you're just trying to figure out what is the smallest number that both of these things can create. Or if you're not good with mental math and you need a formula, what you are going to do, all right, is you're just going to multiply the two together, and then you're going to divide by the number that goes into both of them. Most of you, most people are relatively better at figuring out what number goes into something than they are trying to find a least common multiple. So let's put this into practice. That's the first page. Let's put all these ideas into practice. So here we go. So, first thing, just a reminder, so the mental math process to do here, I don't care which process you use, nor should you, but the mental math process is this. So if I'm doing LCM, and I'm doing this mental math, I suggest that you just start with the largest number of the two. So the largest number is 7. So start writing the multiples of 7. So the multiples of 7 are 7, 14, 21, 28, 35, right? 42, and I'll do one more, 49, okay? So now we take a look at this, right? And what we're going to look for is we're going to look for the first number in that group that is divisible by 6. So what I'm just simply saying to you here is divide each of these by 6. And what is the first one that 6 goes into? Evenly. So 6 does not go into 7, 6 does not go into 14, 6 does not go into 21, 6 does not go into 28, 6 does not go into 35, but yet finally what we have is that 6 does go into 42. So the LCM of this problem is 42. Now, for most of these problems, okay, for elimination, you'll be able to do this method, all right? But if you're not good at that, or you miss a number in that step, you could potentially, it won't harm you, ironically, in systems. So you just need to list out multiples and find a number that one goes into. If you want to use the formula is pretty simple. The formula is you multiply them, so 6 times 7, and you ask yourself, what number can you divide 6 by that you can divide 7 by? Now, most people are pretty good with this because you've been simplifying fractions since 4th or 5th grade. So think about what number could you use to simplify 6 and 7, and the answer to that is, well, there's nothing besides 1. So all you do is 6 times 7, and you get 42 immediately, and there you go, the LCM is 42. All right? So putting that all together and utilizing the elimination method, all right, to solve these systems. First off, do the A's equal A's and do the B equal B. Now again, it's really, honestly, it's this absolute value, okay, of the A's and the B's. But you can ignore that. We're just looking at the number. So if you want to look at the number and then come back, separate the two, that's what we do. All right, so 4 and 3, not the same. 7 and 4, not the same. So because neither of them the same, I need to pick a pair. Pick a pair that you can find the LCM of. It doesn't matter. If both of them are not the same, you honestly don't need to worry about which one. Yes, maybe sometimes one works out better than the other, like whatever it is. But for this one, you're just going to find the LCM of the x's or the y's. It doesn't matter, okay? So in this case, I'm just going to choose x's. So I am going to determine the LCM of 4 and 3. All right? So if I'm doing mental math here, I would go 4, and then I'd go 4, 8, 12, okay, and then 16. And usually you can go about 4 or 5 out and then test and then come back to it. And if it doesn't work, continue, okay? So I'm going to test at this point. So divide by 3, divide by 3, divide by 3. Finally got it. So the LCM is 12. So the LCM of 4 and 3 is 12. So now what I need to do with that LCM, here's the important piece, okay? I need to turn both my x's into 12s. And to do that, I utilize the multiplication property. So unfortunately, neither of them are already 12. So what I have to do is I got to convert both of these, okay? So I'm going to convert both of them. So you just simply ask yourself, how do you write the first equation down? So negative 4x plus 7y equals 8. And I suggest doing them separately. Maybe it's a little bit better. But you're going to ask yourself, how do you turn 4? And don't worry about that it's negative. Don't care about the sign. You just want the number to become 12. You'll worry about the sign when we do the addition or subtraction property. So I want 4 to be 12. Well, how do you turn 4 into 12? Done by the multiplication property, you multiply 4 by 3. So therefore, the answer, you go like this, put a 3. Multiplication property states, got to multiply both sides. So here we go. 3 times negative 4 is negative 12x. 3 times 7 is positive 21y. And 3 times 8 is 24. So there's system 1, okay? So I solve it, and I go like such. And then I go, I'm going to place that system to start off with. 12x plus 21 equals 24. So as I alter them, I will place them into my new system. Then I'm going to alter equation number 2. Equation number 2 was 3x minus 4y equals negative 6. Again, you're going to ask yourself, the x, okay, because you found the LCM of the 4 and the 3, which were the x's, you need to turn that x into this x into a 12. So how do I do that? Well, in this case, you multiply by 4. So multiply by 4, both sides of the equation. So now I get 12x minus 16y equals negative 24. Place this into my system up there. So I get 12x minus 16y, okay, equals negative 24. So from here, now that we have the variables the same, now we're going to decide what do we do. Do we do the property of addition or do we do the property of subtraction? If they are opposite numbers, so the x's, if they are opposites, we'll add. If they are the same, we will subtract. So that's why we don't really care about the sign till we get to this step. So at this point, I am now going to decide, are the 12s opposite or the same? Well, negative 12 and 12 are opposites. So we add opposites. So again, what I like to do is put a plus sign between everything. So here we go. So I get negative 12x plus 12x, that's 0. I get 21y plus negative 16y is going to be 5y equals 24 plus negative 24. This is an extremely, crucially important piece that if one side of your equation becomes 0, everything on that side becomes 0, you must write a 0 down below. No variables, no nothing. It just needs to get that 0, okay? So now at this point, I have 5 times a number equals 0. Now, logically, I would hope that you would know that any number in the world multiplied by something to create 0 must have been multiplied by 0. But if you didn't, you go through the process of divide by 5, and y equals 0 over 5 is 0. So I've got y is 0, but I'm not done. So now we finish this off like we did when we did the first one. So you're going to pick an equation. So I go back to my originals. I like to go up here. All right, so the reason I like to separate these things out down here is because now I can go back to this. It's not mucked around. I'm not going to be crossing things out, working within there, and having to look through my work. So I'm going to write the second equation out. I could choose the first, but I chose the second. So 3x minus 4y equals negative 6. Wherever I see a y, I can now substitute in 0. So 4 times 0 equals negative 6. That becomes 0. I'm left with 3x equals negative 6. Divide by 3, I get x equals negative 2. And there you have it. This is the beginning process. So I get the point negative 2, 0 is the place where those two lines intersect. Again, that is a point of intersection. So let's continue on with this process. So just another one, okay? So again, we ask ourselves, every single time you ask yourself this question, does A1 equal A2? Does B1 equal B2? So essentially, you could ask yourselves, are the coefficients of x equal? Are the coefficients of y equal? 2 and 7 not equal. 7 and 5 are not equal. So what you now need to do is find the LCM. Now, in this case, neither of them are equal, and looking at the numbers, I can't turn one directly into the other, meaning I can't turn 2 directly into 7. I can't turn 5 directly into 7. So what I'm just going to simply do in that case, I'm just in the habit of, I just always alter the x's. So I'm going to find the LCM of 2 and 7. Again, we don't worry about sign at this point, okay? So at this point, I'll just use the formula, all right? So the formula states, multiply the two numbers together that you're trying to find, and then ask yourself, what is the largest number that you can divide 7 and 2 by? Well, it happens to be 1. So therefore, the LCM is 14. So the LCM of those two numbers. Now, what this LCM tells me is that I must convert this 2 into a 14 and this 7 into a 14. So I like to make my conversions part. So I literally write this out. Okay, convert. So my convert. Okay, well, I should write probably conversions to make this sound a little bit more English, right? Come on, math teacher. Okay, conversions. All right, so here goes my conversions. So I'm going to do one equation at a time. I'm going to set this up next to it. That's my system. After I convert it, I'll place it into the system. Okay, so here we go. One at a time. The first one, negative 2x minus 7y equals 22. How do I turn 2 into 14? Well, you multiply by 7. And then multiply both sides by 7. That's a crucial part here. So 7 times negative 2 is negative 14x. 7 times negative 7y is negative 49y. 7 times 22. All right? And if you don't know how to do this, it's literally 7 times 20, which is 140, plus 7 times 2, which is 14. So it makes it 154. Okay, so if you notice there, I use the sneaky property called the distributive property there. But anyhow, there's my first system. Negative 14x minus 49y equals 154. Plug it in there. Now go back to the second equation. Pluck it out. It is a 7x plus 5y equals 1. What I'm going to do is I'm going to go again, ask myself, that 7 has to become a 14. So how do I turn 7 into 14? Well, I multiply it by 2. So multiply it by 2. Okay, multiply by 2. So this side becomes 14x plus 10y equals 2. Now I plug that over here. So 14x plus 10y equals 2. And from here, I now have the thing that I'm looking for in the beginning. A1 is equal to A2. So I can now ask myself, should I add or subtract these? If they're opposites, add. Same, we subtract. In this case, they are opposites, so we add. Okay, so I like to put a plus sign, okay, a plus sign in between all of them, just to remind myself that I'm adding here, okay? So, at this point, what I'm going to do is I'm going to go ahead and add them. So, negative 14 plus 14 is 0. All right, negative 49 plus 10, okay, is going to be negative 39. So, I get negative 39. Y equals 54 plus 2 is 156. Divide both sides by negative 39, negative 39. You will get y equals, type this one into your calculator and you'll get a 4. All right? So then with this 4, I take that 4 and I pick an equation from the beginning. So here's my beginning. Pick one of those, plug 4 in for y. I'm just going to choose one equation and I'm just going to pick the second one. Does it matter which one you pick? The answer to that is absolutely not. Pick one of them, it will work in both. So 7x plus 5y equals 1. Now wherever I see a y, because I solved for y, I place a 4. So 7x plus 5 times 4 equals 1. Okay, so now I get 7x plus 20 equals 1. Moving on from here, I subtract 20 from both sides. Subtract 20 from both sides. and I get 7x equals negative 19. Now, this isn't going to be pretty, but not everything works out to be pretty. So we divide by 7, okay? Now, we have a fraction on this side, okay? And a lot of people get tripped up by this. Don't get tripped by the fact that it's a fraction. It's okay that it's a fraction, all right? Don't worry about that piece, all right? What you do need to worry about, though, is that this fraction, okay, so I've got x equals, just rewrite the fraction, 19 over 7, okay? And what you have, there's an answer. It's not pretty. But the reason that we have this elimination method is to find solutions to answers that aren't nice, right? That's the reason we do this. Because if everything was nice and worked out to be a whole coordinate pair, then we would just graph everything. I would just teach you how to rearrange these and I'd graph everything. But that doesn't happen. So I want people to see that it doesn't always work out nice. Now, sometimes your teacher just gives you something that works out nice, but that's because they want to check that you know the method and they don't want you to get scared by the numbers. Don't be scared by the numbers. Fractions are numbers, okay? So on to the next one. All right, so we've got this thing. It's an error analysis, okay? So basically, we're just going to check the process. We're going to go through the process that we just went through and see if somebody missed anything, made any mistakes along the way. So here we go. This person, like me, decided to do the LCM of the x's, all right? They noticed that the x's weren't the same, nor were the y's the same, so they went through, did the LCM here. All right, so all we're going to do here is we're not going to worry about making corrections for this one because we'll just do the process in another video. All right, another problem. We'll go back through it. So this one, let's just identify where the mistake was made. All right, so the mistake is made here. All right, when we take a look at 5 and 6, okay, they did the formula. 5 times 6 is the largest number that goes in the 5 and 6 1. You betcha. So 5 times 6, 30. 30 divided by 1 is 30. Okay, so now we go in. Now let's just check. They turn everything into a 30. So 6 and 5. Yes, 6 times 5 makes 30. Okay, now let's just check that they did distributive property correctly. So 6 times 4 is 24. 6 and negative 14, negative 84. Yes, that is correct. 5 times 6, 30. 5 times 6, 30. 5 times 6, 6. Whoa! Okay, we didn't have to get very far to realize that they made a mistake. So what was the mistake they made? And this is a common mistake, and we want to avoid this mistake, okay? And the very common mistake they make is people forget to multiply this constant. They place this information over here, right? But they forget to multiply this side by that 5. And they do this side, right? So don't forget, when you multiply something, the multiplication property is extremely important. So the mistake in this one, if I had to explain this on a test, would be that the person made a step in the first step, made a mistake in the first step. What did they do wrong? They distributed improperly. What should they have done? Distributed properly, right? And what they would have done to distribute properly was they would have multiplied both sides of the equation by 5. So they didn't properly execute the multiplication property of equality. All right, so let's go back through the process again. I'm not going to fix this one and go through it just for sake of time, but because I'm going to show you 2 more examples of problems. So here we go, another example. So what I've got going on here is I'm going to look at this again, and we got to figure out, are my x's the same and are my y's the same? And the answer to that is they're not. So the only method I have here is LCM. Now, LCM. Now, I always told you I usually always do the x's. Well, let me show you something about this shortcut that I was talking about. You can always do the x's. You don't ever have to change that method if you don't want to. But what you can do here is notice that you see 8 and 10 and 4 and 5. Usually, the smaller pairs of numbers combined together is going to have a smaller LCM, which means you'd have a smaller multiple. So in this case, I'm going to change this y coordinates into their LCM. So as opposed to using the x's, this time I'm going to use the y coordinates. So I'm going to find the LCM, okay, of 4 and 5. So the LCM of 4 and 5. Well, how do you find the LCM of 4 and 5? If you're using the formula, it's 4 times 5, and then ask yourself, what could you divide 4 and 5 by that is the same thing? All right? Well, you can divide 4 by 1, 4, and 2. So which one of those does 5? And it's just the 1, so this is 20. 20 divided by 1 is 20. Okay? So the LCM is 20. So what that means is that I am now converting. Okay? So here comes my conversions. And like I said, do one at a time. So here go my conversions. One equation at a time. Extremely important that you do that. So write the first equation, 8x plus 4y equals 20. Now, just remember, okay, this is the y's. All right, so you're focused in on the y's. So how do you turn 4 into 20? You multiply it by 5, okay? Property of equality states you must do it to both sides, so put a 5 on that side. So here we go, distributive property. This becomes 40x plus 20y equals 5 times 20 is 100. So again, what I like to do is start my system, move that over right away, so I get 40x plus 20y equals 100. Move on to your next one. So the next equation, now we write it out. So it was 10x plus 5y equals 25. Again, we're focused in on the y's, turning them into 20. So I look at the y coordinate, I remind myself, okay, how do I turn this into 20? Well, I turn it into 20, and nice enough, up here in the LCM, I multiply it by 4. So I go down here, and I go, okay, multiply this side by 4, and this side by 4. So you ready? Here we go. So 4 times 10 is 40. So 40x, 4 times the 5 is positive 20y, and 4 times 25 is 100. Okay. So what I've got going on here is my next system, it goes up, and it's 40x plus 20y equals 100. Wait a second here. Those are the same equations. So what does that mean? Well, I got to figure out an x and a y that I can plug in to the first equation, that I can plug in the second equation that gives me the same answer. But they're the same equation. So it doesn't matter what you plug in. All right? It doesn't matter. So let me show you mathematically how you can determine that regardless of what you plug in, you're always going to get the same answer. So we ready? Here we go. Let's mathematically show you. So again, we made our y's the same. So I'm focused in on my y's right now. I'm not going to focus on the x's. I get it that they're the same, but we're focused in on the y's. So how do I turn 20 and 20 into 0? That is the subtraction property because these aren't opposites. So I'm going to throw a minus sign in between everything now, okay? So what is 40x minus 40x? It is 0. What is 20y minus 20y? It is 0. Now, if everything crosses out on a side, you must put a 0. All right? Don't put a variable with it. Everything's crossed out. There's no variables. There's no nothing. It's just 0. Equals 100 minus 100 is 0. So this is now a statement. It is not an equation. Equations have variables in them, okay? This is now an equality statement. So 0 equals 0. What is that telling me? Well, 0 equals 0 is literally telling me that every single thing in my equation was the same, so therefore I have the same equation. So therefore, because I have the same equation, all x's on y's on both of those equations are identical. So these are called coinciding lines, but the answer is infinite solutions. Okay, so there are infinite solutions here. Some teachers want this to be called all real numbers, so the other answer that you'll see commonly is that the answer to this is all real numbers. Okay, so there are infinite solutions, and the answer is all real numbers can be used. Doesn't matter what you have. All right, so on to the next one. So we go on to the next one here, and we take a look at this one again. And we go and we ask ourselves, okay, are the x's the same? Are the y's the same? So we look at them, 3 and 7. Ignore the sign for now, right? Absolute value means ignore sign, so we're just looking at the number itself. 3 and 7, nope. 6 and 10, nope. Okay, 6 and 10 feels to me like it's going to have a larger LCM than 3 and 7, so I'm going to do the LCM of 3 and 7. So I take this and I go, okay, what is the LCM of 3, okay, and 7? Now, I'm a guy who likes to use the formula. I think it's the quickest way, actually, for most people and myself. So I do 3 times 7. What goes into 3 and 7 is 1, so the LCM is 21. Okay, easy enough. So here we go, moving on forward. So now I do my conversions. Okay, so here comes my conversions. And obviously, you don't have to write this word conversions like I do, but I'm just writing it for the video purpose. So here we go. Write the first equation. The first equation is 3x plus 6y equals negative 3. And what's helpful is, where did that 3 and 7 come from? It came from the x's, so just remember that you're trying to turn the x's into 21. So how do I turn 3 into 21? Well, I multiply it by 7. So multiply both sides by 7, and I will get 21x plus 42y equals negative 21. So what I will now do is I will make my system over here to the right. And you don't have to write this squiggly thing either. I'm doing it, so I won't write it this time, okay? So here we go. I write my system over here, 21x plus 42y equals negative 21. And then I will go to the next equation because I got to convert both of them. So I will write that out. So negative 7x plus 10y equals negative 17. And what I'm going to do is I'm going to multiply this now by 3, right? So how do I turn 7 into 21? Multiply it by 3, so multiply both sides by 3. So this becomes negative 21x plus 30y is now going to be equivalent to good old negative 51. So now we place this up here with the other system. So negative 21x plus 30y equals negative 51. So now we look at our thing. We're going to combine these. So I'm drawing an arrow or a line here. So 21 and negative 21. Are they opposites or they're the same? They're opposites. So if they're opposites, I'm going to add. So add. So 21 plus negative 21, 0. 42 plus 30, okay, is good old 72y equals negative 21 minus 51 is negative 72. Now I can go ahead and break apart the multiplication by division, divide both sides by 72. I get y equals negative 1. When I have y equals negative 1, I take that information and I'm going to plug it into an original equation. So I'm just going to grab the first equation because I can. So I'll get 3x plus 6y equals negative 3. So 3x plus, wherever I see a y, I replace it with a negative 1, so the 6 stays, multiplied by negative 1 equals negative 3. So I get 3x minus 6 equals negative 3, add 6. Notice that we're using this addition of opposites constantly, so 3x equals negative 3 and 6 makes 3, divide by 3, x equals 1. Final solution, where these two lines intersect, is at the point 1, negative 1. And there you have it. There's the final answer. So after this, just so you know, if you were in my class, you will have a homework page with this. So if you are part of my students, please would you complete this homework where it's labeled at the end. So I want to check and see some review problems. So thank you for watching the video, and I hope it helps for you. And then also on the last page here, there are some other review problems that deal with systems or just equations in general of lines.